Hello everyone, it's Wilson here. Today I want to continue to talk about how to evaluate integrals by interpreting the integral geometrically so that we do not really need to use the antiderivative, we do not need to use the fundamental theorem of calculus. So we're actually doing calculus without using calculus. Okay, now let's do this problem. So we have this integral and then you can see that the integrand is x plus 1. So we have the function is y equals x plus 1. And so as you can see here, this is really just a line, a plane, right? So let's graph it first because we are going to interpret this integral geometrically. So how do you graph this one? It's easy, right? From your basic algebra class, you should have known how to graph this x plus 1. So the y-intercept is really just a 1 right here. Okay, so we have the 0, 1, which is the point on the y-axis. And then now, as you can see, the slope is 1. That means you need to go up 1, go to the right 1, and then you get the next point. And then, so if you want a few more points, then you can actually just come up a few more points right here. And then I think there is one more point here, and also there was another point here. And then you may say, why do I draw so many dots on the xy plane? It's really because I want to make a line segment connecting that dot and this dot right here. Why? Because the interval is from -1 to 4. And so we only really just care about this portion of the line. Okay, it's from -1 to positive 4. So let's graph it. Let's graph it here. So we have that. And then, so what is this integral? What is this integral? This integral represents the area under this line segment right here. Okay, so what is the region that's bounded by this line segment? Also bounded by x equals -1, x equals 4, and then also the x-axis. It's a triangle. So let's just draw that right now. Okay, so I gotta draw it, right? So let me draw another line right here. And so you can see that we have a triangular region here. So let me do the shading right here. And see that it's a right triangle. So that means coming up with the base and coming up with the height would be easy, right? For this right triangle here. So how many units do we have for the base? We have 1, 2, 3, 4, and 5. So we have 5 units. So the base, right, is equal to 5. And now, what is the height? 1, 2, 3, 4, 5, 5 units also, right? So we have 5 units. So the height for the triangle is also going to be 5 units. Now, yeah. So remember this point right here, this point that we have here is actually, what is that? That's 4, right? Yeah. Okay. So if we have the base, we have the height, then we can actually find the area of the triangle, and then we get the value for this integral. Okay. So the integral from -1 to 4 of x plus 1 dx is actually equal to the area, right, of this green right triangle here. Okay, and then what is that equal to? It's going to be 1 times the base, and then also times the height. So you know the area for finding, you know the area formula for finding the area for triangle, right? So it would be this 1/2 times the 5, and then times also the 5, right? And then, so the answer will be 25 over 2. And so that's the value for this. And we didn't find the antiderivative for x plus 1. We didn't use the Fundamental Theorem of Calculus part 2 to plug in the limits into the antiderivative. We only just interpret the integral as an area, and then we find the answer. See that? That's really fun, right? It's actually quite fun to do. Hope you like this video. To help me make math learning available to everyone, please share my videos to others and subscribe my channel. It will really give me a lot of support to make more videos. Let's work together to help students and children learn math more easily. Thank you for watching this video. I will